All right, so I wanted you to come up with a relationship between the force you're applying and the mass. And most of you did a really good job of coming up with a graph that had the quantity of what? What did we put on this vertical axis? Force. And what quantity did we put on the horizontal axis? The mass. And you guys measured it in grams, and that was perfectly fine. Okay? All right. So when you graphed this, and I get to make these look real pretty, but you had maybe some points that look like that, and then maybe you had some points that look like this, and then that gave you a best fit line like that, and a best fit line like this, where the high slope one was the one that was not moving, right? Or it should have been for most of you. And then the lower slope was when it was moving. Okay? So let's draw a let's look at, what is the equation? You guys did a good job of drawing the force. And this was the applied force. The applied force. This is what you are applying to the object. And then you got some slope number, and I'm going to write the word slope because the symbol you use in math for slope is m, right? What does m mean in physics? Mass. So that's going to get really jacked up. So let's just, I'm going to use the word slope right there, and then what's on the x-axis? Mass is on the x-axis. And then some of you had a slight intercept or a significant intercept, but that just goes back to your experimental error. Okay, so we had the force applied is equal to the sum slope number times m. Now let's look at the free body diagram. Remember yesterday we talked about free body diagrams of the object when it's not moving. What's a fancy science word for not moving?
Still.
I heard it, static. Static. That is the fancy word for not moving. Okay, when we draw a free body diagram, we draw something like a circle or a square or a dot to represent the object. And then we're going to draw the interactions with that object. So, think about all the things that are interacting with our block. The Earth's interaction would be which way? Down. And you guys yesterday were drawing those arrows. And let's call that the force due to the Earth, the force of gravity. Okay? And then I also heard friction. Well, what's that the interaction between? The block and the surface, right? The block and the wooden surface it was on. And which way would friction point? If you're pulling it to the right, which way would the friction point? To the left. And now I'm going to make, so this is the force of friction static. And I'm going to put a little S there. So I love some subscripts. What else was interacting with our block? You were pulling on it, right? Did you apply a force? Yeah, you sure did. And you were pulling it to the right. So just call it the force due to you, or the force that you applied. How about that? Force applied. Is there anything else that was acting on this this block? So far we've got that you applied a force to the right. That was your interaction. The surface was applying a friction force back on the object. The Earth was applying a force down on the object. What do you think? So the table applies a force. Oh, and that is up. Okay. Now we call that force, you can call it the parallel force. Pardon me, the perpendicular force. You can call it the table force, whatever you want to call it. But we steal a word from math, normal. Do you remember in math class, a normal line is perpendicular to another line? They're normal to each other. So it's a math word, but we have the normal force.